going to do we're still in chapter 8. I'm going to do a variation of problem 5. I don't like the way they wrote it, so I'm changing it. It says a 1,500 kilogram car. So here's my car. Oh yeah, it's an ugly car. You got the idea. Here's the car. Looking at it from the back. Right, here's the trunk of the car. Here's the steering wheel. All right, 1,500 kilogram car is going to make a corner to the right. And the corner has a radius, has a diameter of 200 meters. And it's going at a velocity of 25 meters per second. We want to find the coefficient of static friction so that that car can make that corner. All right, remember we talked about this back in chapter 4, but when a wheel makes a corner, when you're steering, or even when your car is going in a straight direction, your car is not skidding, so it's not kinetic friction, it's static friction. The rubber in your tires and the road, when an object rolls, it's actually just putting new material down all the time, but it's not sliding. You don't want it to slide, then you lose control. So that's why it's static friction. So it's the static friction between your wheels and the road that makes you turn. When you lose that static friction, you can't turn. Which happens like if you're driving on ice, you go along and all of a sudden you try to turn your wheel and you just keep going straight. That's because Newton's first law says you got momentum in a straight direction, you're going to go in a straight direction. If there's no friction between your tires and the road to make you change your direction. All right, so how do we do this? We're going to do we're going to do the problem the exact same way we do every other one. We're going to do a free body diagram. So here's the car. We have gravity, we have a normal force from the road, and we have the friction, the tires creating a friction force, and it's a friction force that's trying to make us turn to the right. Okay? All right, so then I'm going to do F net x is equal to the friction force. Okay, because they're both already on the axis. So this is the x-axis, y-axis. And it's making a corner, so it's making a horizontal circle, so this has to become mv squared over r. So this is mv squared over r is equal to the static friction force, which is mu sub s times the normal force. But in this case, mu sub s times the normal force just has to equal gravity because F net y is equal to normal force minus mg, but this is 0 because it's not accelerating up or down, so the n equals mg. So we end up with mv squared over r is equal to mu sub s mg. And the m's cancel. We can solve this, sorry, canceled the wrong one. The m's cancel. We're going to solve this for mu sub s. So mu sub s is just going to be equal to v squared over gr. I divide both sides by g. And I know all that, so I'm going to plug that in. That's 25 squared over 9.8 times, actually 100. We've got to be careful because that's the diameter. We need the radius. And when you do that, you get, pull out Mr. Calculator here. (25 squared) divided by the quantity 9.8 times 100, and you get 0.6377 or 0.64 is our coefficient of friction. Remember, there's no units on the coefficient of friction. It's actually just a ratio. And that's how you do it.